Okay, so we're going to finish up trig values today. So we're going to look first at how to convert from degrees to radians or radians to degrees. So what I drew here was just the axis with our radians on it, which we talked about last class, how to find where they go for different angles. So here's 0, up on the positive y-axis is pi over 2, pi, 3 pi over 2. And then for degrees, those would be 0, 90, 180, 270, back to 360. So if you want to convert from degrees to radians or radians to degrees, what you want to do is just pick one of any of them that you already know. So what we already know is that 90 is equal to pi over 2, or pi is equal to 180. Okay. So we can do this a couple different ways. We could draw the angle like I showed you if it was in radians, and then you could calculate it in degrees by looking at where it lands. Okay, but we're going to do it a little different. So we're going to take any one value that we know. So start with something you know. So for example, we might say, okay, pi is equal to 180 degrees. So that's one that we know, but it could be any of them. The rest of them have fractions, so this is the only one really with no fraction in it. Okay, so we start with that, and say, for example, we wanted to find three pi over 4 in degrees. So we want to convert 3 pi over 4 to degrees. So we start with something we know. I'm just going to write it again here. And really what you do is just change it so that on this side, where we have the radians, we have 3 pi over 4. So what would we do to the pi to get it to look like 3 pi over 4? Multiply by 3 and divide by 4. So we're going to, on this side, we're going to, so we've already got the pi there, and we're going to multiply by 3 over 4. Now, if you do that to one side, you have to do the same thing to the other side. And that's it. You're done. 3 pi over 4 is equal to 3 times 180 over 4, whatever that is. So what can we do here to simplify this? Well, 180 is 18 times 10, 4 is 2 times 2. I mean, you can cross off before that, but this is how we did it when we did it early on. Break them up small. Okay, what cancels? Both 2's? All right, and what do we have left? Now you can do this in any order. 135, so I would say 9 times 5 is 45, and 45 times 3. 45 times 3 is 90, 135, yep. So you just make one side what you already know, and then you work out the other side. So this is the easy way. Now, if I gave you, say, find the radians, say, convert 225 degrees to radians. It's a little bit trickier to do it this way, but we'll look at it. So again, start with something you know. So we know pi is equal to 180. Now, this one's a little trickier. Up here, we wanted this to be 3 pi over 4, so we just multiplied by 3 and divide by 4. Here, we want this side, the degree side, to be 225. So that's not as obvious what we do. So what you can do is choose a different one to start with. That would be one option, something that's better. if there's not really one that's better, then you can reduce this. So we could, for example, if you divide by 180. So we're going to divide by 180. We'll also divide this side by 180. So we will have something that we did to both sides. What's 180 divided by 180? 1. Okay. So this is called going through 1. Okay, so we made it now 1 instead. Now what do we need to do to make it look like 225? Multiply by 225. So we're going to multiply both sides by 225. So now we have 225 pi divided by 180 is equal to 225 degrees. And there's our answer. We just need to simplify it. Same way we did before. So we're going to simplify 225 pi over 180. 225. It's 25 times what? Think of quarters. $2.25 is how many quarters? So 25 times 9, and we've got a pi. This is 18 times 10. 25 is 5 times 5. 9 times 2. Okay, and again, you don't need to break it up this way if you want to just cross them off. Okay, so I've simplified it so that I can cancel a few things. What cancels? A 5, a 9, anything else? No, so we're left with 5 pi over 2 times 2, 4. So 225 degrees is 5 pi over 4. Okay, and that's all we're going to do with that. You can practice a few on the homework, but really what happens when you get to calculus is you just use radians. You don't need to convert because you don't have anything in degrees to convert to radians. It's just in radians, okay? But it's good to know how to convert those. So that's it for that part. Okay, the next part. So we are going to say evaluate and we'll number them. Sine of 2 pi over 3. Okay, so this is what we're going to do, is going to take sine, costan, secant, cosecant, and cotan and evaluate different values for them. So that's, we're going to start with just sine, costan, and then I'll tell you how you do the other ones. So we learned enough last class to be able to do all of this. Okay, so here's the steps. I'm not going to write the steps out each time, but we'll write it out for the first one. So step 1 is to draw the angle. This doesn't look like there's a problem, but the screen went out up here, so I can't see what I'm doing or what time it is. Okay, so tell me if that goes off, because I won't notice. I can't see it anymore up here. So draw the angle. So to draw the angle, we're just drawing the 2 pi over 3. So you draw your axis, and what does 2 pi over 3 look like? So the 3 means how many pieces we're cutting the pi into. Okay, so this is the number of pieces. And the 2 is how many pieces we want. So here's our pi, just on the top, and we're cutting it into 3 pieces. So we're ignoring that, 1, 2, 3. And how many do we want? 2. Here's your start. It's positive, so we're going in this direction. We want 2 pieces, 1, 2, and so here is 2 pi over 3. So that's step 1. Step 2, identify the reference angle. So the reference angle is the angle between that terminal arm, that cut mark. So the reference angle is the angle between the terminal arm, which is the cut mark we made, and the x-axis. So if we look, it's not the angle that we went through, it's the size of the piece between that cut mark and the x-axis. So here's the terminal arm. And here's the x-axis. And right in here is called the reference angle. You're going the smallest piece. Okay, so it's usually one piece. How big is that piece? It's a third of the pi, so it's pi divided by 3. So the reference angle in this example is pi over 3. So it's the size of that piece. Okay, and it's always between the terminal arm that you drew and the x-axis. Step 3. Okay, so from the table that you have memorized, the values you have memorized, you look it up. Sine of the reference angle, sine because the question was sine, and pi over 3 because that was the reference angle. So you look it up. What is sine of pi over 3? Sine of pi over 3 is root 3 over 2. Okay, so we say, okay, that's equal to root 3 over 2. Now, that isn't the answer. The last step tells you what sign it is, whether it's positive or negative, and that's the cast rule. Use the cast rule to determine whether the angle is positive or negative. So how do we do that? Remember, it starts down here in the bottom corner. The A is in where it's all positive. Both X and Y are positive in A. So which quadrant did it land in? The S. So what does S mean? The S means that sine is positive in that quadrant. The A means they're all positive, the T means tan is positive, and the C means cos. So since it landed in the S, it's positive. And 5 is right the answer. Which is 2 parts. So you write sine of 2 pi over 3, that's the question, is equal to plus, because we landed in the plus quadrant, and the reference angle, root 3 over 2. And remember, I showed you that sine, the values just repeat and repeat and repeat. The cast rule is telling you where we land, above the axis or below the axis, either positive or negative. So you need the cast rule, and you just need to know what the reference angle is, because the answers are all the same for pi over 3, or for any pi over 3. This one's 2 pi over 3. The answer would still be 3 pi over 2 for 5 pi over 3, 11 pi over 3, 101 pi over 3. They would all be root 3 over 2. It's just whether they're plus or minus. And to know whether they're plus or minus is the cast rule. Okay? So, now we're going to do it without writing all those steps. So it's much quicker than a whole page long to find each one. And these are supposed to be really quick to do. So we're going to do it all on one little drawing of the angle. So let me give you another question. Cos of negative 5 pi over 6. So our 5 steps look like this. Draw the angle. Now, how do we draw this one? Negative, so we have to go backwards. We're cutting the pie into how many pieces? 6 pieces. And we're going backwards because the angle is negative. We still start at the same point, but we're going in the opposite direction. And we want 5 pieces. So 1, 2, 3, 4, 5. This is our terminal arm. So our reference angle is right in here. What size is that piece? Pi over 6. It really is whatever is right here, the size of the pieces, as long as it's reduced. Okay, so it is best to draw it and look, because sometimes if you didn't notice that you could reduce this fraction, I'll give you one that's not reduced after to show you what I mean. But it's whatever size that piece is between the x-axis and the terminal arm. So pi over 6, it's usually just that value that we cut the pieces into. Cast rule, write that right on to this, C-A-S-T. What quadrant do we land in? T. So that means tan is positive. Are we looking for tan? No. So cos, this means that tan is positive, so that means cos is negative and sine is negative. And we're looking for cos. So our answer, negative, because of the quadrant we landed in, is T, not the cos one. And our value is whatever cos of pi over 6 is. Root 3 over 2. So there's your answer. Okay, so you draw it, use the cast rule, and just look up the value. So the cast rule gives you the sign, and the table gives you the value. Now we can land, instead of in a quadrant, we can land on one of the axes, which actually makes things a lot easier. So this one, for example, when you go to draw your angle, pi over 2 is here. That's 1 pi over 2. It's positive, so we're going in the positive direction. 2 pi over 2, 3 pi over 2, 4 pi over 2, one more, 5 pi over 2. So where do we land? We land on the same one as pi over 2. If you land on an axis, so I said, and then that is the answer. You don't need to do cast rule or anything because we're not in a quadrant. What it's saying is that sine of 5 pi over 2 is the same as sine of pi over 2. So we just look up sine of pi over 2 on our table, which is what? Sine of pi over 2 is 1, and 1 is the answer. Okay, so if you land on an axis, just look up that value, whatever axis you land on, and that is the answer. Okay, so what about tan? Okay, so this is what I'm talking about. We don't have pi over 8 as reference angles. You're not going to cut your pie into 8 pieces. You look and say, could I reduce that fraction? It's not that they don't exist, but you would need a calculator. It falls between values that we don't know, right? But if this reduces, does that fraction reduce to something we know? So 6 pi over 8. The 2's cancel, so it's the same as, whoops, 3 pi over 2, or over 4, sorry. Right? It's the same as 3 pi over 4. So sometimes that angle's not reduced. You have to reduce it first before you go through. So this is what we're looking for, is 3 pi over 4. So we draw it. That is pi cut into 4 pieces in the positive direction. And how many do we want? 3, so we're right here. Our reference angle is between that line and the x-axis. Is 1 piece, so pi over 4, 1/4 of the pi. And then what quadrant do we land in? Sine is positive, so what's tan? Negative. So the sine, this is saying that tan is negative. And our reference angle, we're going to look up tan of pi over 4 to get the answer. Tan of pi over 4 is 1, so the answer is -1. So far, so good? Yep.
So the reference angle is always what's left after?
Yeah, no. Okay. Yeah, no. Okay. Cos of 7 pi over 6. I'm going to answer your question with this example. So cos of 7 pi over 6. Draw the angle. So we're cutting it into 6 pieces. Do we need more than 1 pi? Yeah, because 6 pieces, we need 7, so we need to have 1 more pi down here. Cut that one into 6 pieces, so now we have 12 pieces altogether. We're positive, so we're going to go up. 1, 2, 3, 4, 5, 6, 7. The reference angle is always the angle between the terminal arm and the x-axis. Always the closest. If we're in this quadrant, it's always going to be here. If we're in this quadrant, it's here. Yeah. So here's our reference angle, and how big is that piece? Pi over 6. So we're going to look up cos of pi over 6, which is √3 over 2. And then our sine, C-A-S-T, we're in the T, so cos is -√3 over 2. Okay, other questions? So you go forward or backwards. You draw the angle first, look up the reference angle and the sine using the cast rule. Then you can find any value. Now what about secant, cosecant, and cotan? So on our memorized sheet, right here, tan is sine over cos, which is actually how we filled out the tan line, right? So you use it as a division. Cosecant is 1 over sine, and 1 over something, it means the reciprocal. We did reciprocal one other time when we did perpendicular lines. We changed the sign. We did the negative reciprocal, but the reciprocal is take the fraction and flip it over. So it's the reciprocal of sine. Secant is the reciprocal of cosine. They're sort of opposite of what you think, right? This one starts with a C and that's the S. This is secant is cosecant, and this is sine and, secant is cosine, and cosecant is sine. They're sort of the opposite letter, right? Do you see what I mean? This is a C and an S, a C and an S, just so you remember that. They don't match up. And then cotan is tan. That one's easier to remember. So you need to know those three. So for the other three trig ratios, secant is 1 over cos, cosecant is 1 over sine, and cotan is 1 over tan. So if you're trying to find secant, you first find cos and then you flip over the answer. Flip it over. Keep the same sign and everything. So, for example, secant of 2 pi over 3. So secant is 1 over cos, so we're going to first find cos of 2 pi over 3, that answer, as if that were the question, and then we're going to flip it over, and that's the answer for secant. Okay, so cos of 2 pi over 3. So we draw the angle. This is thirds, so we cut the pi into thirds, ignoring that. 2, 1, 2. So 2 pi over 3. Our reference angle is what? Pi over 3. So we're going to look up cos of pi over 3 is 1/2. We look that up. And then the sine. Is cos positive or negative there? Negative, because sine is positive, so cos is negative, and the answer is 1/2. So then, if we know cos of 2 pi over 3 is negative 1/2, then secant is, flip it over, negative, you don't change the sign. Negative 2 over 1 or just negative 2? Same sign, it's just the reciprocal, not the negative reciprocal. When we do perpendicular lines, that's a negative reciprocal, but this is just the reciprocal. Okay, so we'll do 2 more of these. Secant of 5 pi. So that's going to land on an axis. Where's 1 pi? Right here, 1 pi. We're going forward, so we want 5 of those. So there's 1 pi, 2 pi, 3 pi's, 4, and 1 more, 5. So 5 pi is the same as just pi. Now what are we actually trying to find here? We don't want secant, we have no value for that. We need to look up cos. Secant of 5 pi is 1 over cos of 5 pi. So we need to know what cos of 5 pi is, which is the same as what? Pi, because we landed on that axis, so we just look up that value. What's cos of pi on your sheet? -1. So we would flip that over. still negative 1, right? 1 over 1, still negative 1. It's a reciprocal. So it's not the same answer. This is 1 over 1, flip it over, it's still 1 over 1. Okay. What about this one? Draw the angle. Now this is going backwards, so try it. We're going to go in this direction. See if you can land on the right axis. Do we get it? So 7 pi over 2. So here's 1, 2, 3, 4, 5, 6, 7, right here. Did you land in the right spot? So this is the same as pi over 2. Now we want cotan, so we're going to first find tan of minus 7 pi over 2. Which, since we're on an axis, we can just look up that value, pi over 2, which is undefined. Okay, so here's the trickiness. That does not mean cotan is undefined. It does not. I want you to think back at our table. So when we found tan, where's pi over 2? So when we found tan, we did 1 over 0. If we do the opposite of that, or the reciprocal, it would be 0 over 1, which is what? 0. So undefined was like we did 1 divided by 0. If we do the reciprocal of that to get cotan, that's 0 over 1, which is 0. Yep. Then that would be undefined. So the tan of negative 7 pi over 2 is undefined, but the cotan is 0. So if you ever get an answer that's undefined and you're doing the reciprocal, then it's 0. So let's do another one similar to that, but a bit different. Let's say, evaluate cosecant of let's do 6 pi. So because we're looking for cosecant, we need to find sine. Cosecant theta is 1 over sine theta, so we need to find sine of 6 pi, and then we'll flip it over. Yeah, what's sine of 6 pi? So 6 pi, 1, 2, 3, 4, 5, 6. We're back to 0. 1, 2, 3, 4, 5, 6. Back to 0. What's sine of 0? 0. So if we flip that over, what do we get? Undefined. So that's like a 0 over 1, and when you flip it over, you'll get a 1 over 0, which is undefined. You can't divide by 0. So when 0 is your answer and you have to flip it over, it's undefined, but when undefined is your answer and you have to flip it over, it's 0. Okay, so be careful of that. That would be a very common mistake, to get undefined and write 0, and write undefined as your answer. Okay, which is not the case. Okay, the last little bit of this section, it doesn't have any practice questions in here, and there is one on the final exam, but it's an optional question. So there's a couple questions that have a choice. You can do this or that. and this is one of them. So this says, like, let's say solve for theta, or solve for x if I put an x in there. So what are they asking you to do here? Instead of being given the angle and you're finding the answer, they're giving you the answer and asking you to find the angle. So, how would we do that? Go to your table first. So go to the table and look up that sine. Where does sine equal 1 over root 2? Yeah, and that, it doesn't look like that on your table, but that's on. So I had said, like, root 2 over 2. Just look at this. 1 over root 2, if we multiply or rationalize the top and bottom, multiply the top and bottom by root 2, what do we get? Root 2, what's root 2 times root 2? 2. So this is really important to know that 1 over root 2 is the same as root 2 over 2. We see that a lot in calculus. So it's good to remember that those are interchangeable. Okay, they are the same, one and just looks different than the other. Okay. So on the table, we're looking where does sine equal root 2 over 2, or 1 over root 2. Where does it equal root 2 over 2? At pi over 4. So we're working our way backwards. So we say pi over 4 is our reference angle. Okay? So sine of pi over 4 equals root 2 over 2. So our reference angle is pi over 4. Now, this has lots of angles that equal that, because it occurs over and over and over again. If you write your pi over 4 in each quadrant as your reference angle, okay, here we are. Here's your start. Okay, so we've got our reference angle and we have our answer. Is it positive or negative that we want? Positive. Which ones of these are sine positive? The question had a positive, right? This is not the negative angle, we want the positive one. So since it's the positive one we want, we can be here or here. Do you agree? Those are the two where sine is positive. So, starting here, how big is this angle? Pi over 4. So that's one answer. So theta can be pi over 4. Starting right here, how big is this angle? How many pieces is that? 3. 3 pi over 4. Is there more? Yes, because you can keep going around and around. So what's the next one? We don't want these because those are negative. Right? So think about it. Starting here and going all the way around back to the start. How many pieces is that out of 4? 8. One more to get back to this line again. 9. 9, and then how many more? 2 more pieces. 11. What would the next one be? What's that? Yeah, so if we went around twice, that's 16, and one more is 17, yep. Now, the good news is on the test, I don't need 5, I just need 3 is usually sufficient when you're making a list, okay? So you would need 3, not just the 2 normal ones. And I'll do a couple more examples of this at the start of next class.